Hello Year 9s, welcome to another lesson. Please could you pause this video and have a go at the starter activity. Okay, so I'm going to go through the answers now. 5x is 20 when x equals 4. True, because 5 multiplied by 4 equals 20. For the next one, we have 3 multiplied by 2 plus 1, which is 7. So it is false. I'll just write the first letter. 3 multiplied by 2 squared is 12. So this is false. 4 multiplied by 5, take away 5 is 15. So this is true. And 4 multiplied by 5 squared is 4 multiplied by 25. So 100. So this is false. Okay, so the question is, draw the graph of y equals x plus 2. We're going to express the function as, we're going to express the equation as a function machine. So we start off with x, we add 2, and then the result is y. So now we're going to complete a table of values. We've listed 6 different x terms, and we're going to substitute these x values into this equation. So negative 3 plus 2 is negative 1. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. And what I want you to look at here is look at the function machine. Look at the rule of a function machine. We're adding 2 to each x value to get the corresponding y value. If you look at these values here, you also see that they're going up by 1. So you can see a pattern emerging here. 2, 3, 4, 5. If you compare these values, we're adding 2 each time. And as I said, if you look at the term by term sequence, we're adding 1 each time. And that makes sense, right? Because the x coefficient is 1. Now we plot these coordinates on the grid. So negative 3, negative 1, negative 2, 0, and so on and so forth. Lastly, we draw a line through all of these points. Okay, moving on to, and of course always label your line. Moving on to the next example, we're going to follow the same step-by-step process. X take away 3 gives us y. Completing the table of values, so negative 3 take away 3 is negative 6. Negative 2 take away 3 is negative 5. Negative 1 take away 3 is negative 4. And again, if you look at these values, we're taking away 2 each time. So the next one's going to be negative 3. But if you look at the term by term rule, we're adding 1 each time. And again, that makes sense because there is a 1 essentially in front of the x. The x has a coefficient of 1. So plotting these coordinates on the grid is the next step, and of course we need to join the points to make a line, and we label our line. Gonna look at a few other examples. So here it says y equals 2x. So remember, using your knowledge of sequences, if you have a sequence which is 2n, what is the term by term rule going to be? Just think about that. So yeah, starting with x, multiplying by 2 gives us y. Now we're going to complete our table of values. Negative 3 multiplied by 2 is negative 6. Negative 2 multiplied by 2 is negative 4. Negative 1 multiplied by 2 is negative 2. And again, thinking about the question I asked a few minutes ago, what are we whereas in the previous examples we were going up by 1, here you can see we are going up by 2. That makes sense because the x coefficient is 2. Plot each pair of values as coordinates. So let's do that. And draw a line going through all the points. Label your line. Draw the graph of y equals 2x plus 1. So now, in terms of our function machine, there are two operations taking place. One is multiplying by 2, and then we're adding the 1. So complete a table of values. I'm actually going to do it up here. Negative 3 multiplied by 2 is negative 6. Then, so we've done the first bit, multiplying by 2. Then we need to do negative 6 plus 1. That gives us negative 5. So negative 5. Then we have negative 2 multiplied by 2, which is negative 4. And negative 4 plus 1 is negative 3. And again, think about if you had a sequence which was 2n plus 1, what is the term-to-term rule? What are you going up by each time? Remember, the coefficient of the n determines what you're going up by each time. And so look at the pattern. Adding 2 each time, as you can see. And again, if I were to check that using the method up here, using our substitution method, I can do so. 2 multiplied by 2 is 4. So we've multiplied by 2, then we need to add 1. 4 add 1 is obviously 5. So that's right. Now we need to plot each pair of values as coordinates. Sorry. Yeah, we obviously couldn't fit this one in due to the grid, but we can see that it is going to be somewhere here, right? So if we were to extend that line, we could include that last coordinate. Draw the graph of y equals 3x take away 4. So again, two operations are taking place. We're multiplying by 3, then we're taking away 4. Negative 3 multiplied by 3 is negative 9. Negative 9 take away 4. Use a number line if you can't do this in your head. We're starting at negative 9. We're going 4 to the left on our number line, so we end up at negative 13. So that will be negative 13. Negative 2 multiplied by 3 take away, okay, let's just do this first. Negative 6, negative 6, take away 4 is negative 10. Okay. This is... Okay, can you guys spot a mistake? Here, this should be -10. And I'm not just saying that because I worked it out up here. If you look at the pattern, we're adding 3 each time. And that makes sense, right? Because the coefficient of the coefficient of x is 3. So we need to add 3 each time. However, this looks out of place, and the value it should be is -10, because if you start at -13, add 3, you get -10, and get from -10 to 7, you have to add 3. So plotting values on the grid, we get a nice line here. I think you guys are getting the hang of this. We have done quite a few examples. So let's try to do it without using a function machine. We have our equation here, y equals 2 multiplied by x plus 1. Let's just substitute these values into this equation. -3, so 2 multiplied by -3 plus 1 is a -6 plus 1, which is -5. Oh, okay, all of them are up there. But again, you could substitute one by one and you should get all of these values. Again, one easy way of checking to see if they're correct is if they are indeed going up by 2 each time. And we can see that they all are. Plot each pair of values as coordinates. And here is our line. Here we have our first example whereby the value in front of the x is a fraction. So it's 1/2. But again, we still use the same method. 1/2 multiplied by -3 equals -3/2. And -3/2 plus 2 is the same as -3/2 plus 4/2, because 4/2 is the same as 2. So our answer is 1/2. So I'll write 1/2 here. Then we have 1/2 multiplied by -2. Now, if you can't remember how to multiply a fraction with a whole number, -2 is the same as -2/1. And now we multiply this 1 here by this -2. So we get -2. And we multiply this 2 by this 1 to get 2. -2 divided by 2 is -1. And then we need to do -1 plus 2 to get our y value. The answer here is 1. What are we going up by each time here? Well, we're adding a half. So we start with a half, we add a half to get 1. And again, that makes sense because the x coefficient is a half. So we need to be adding a half each time. You could substitute these values into this equation to work out the rest of the values in the table. But I'm just going to use a shortcut. I'll add a half each time. So 1 plus a half is 1.5, which is 3/2. I'll write the value as a decimal as well. Then we have a 2, 2.5, 3, 3.5. And here we have 2, 3, 5/2, and 7/2. Now let's plot these coordinates. So let's use this one, for example. That is 1 and 2.5. So you put the little x halfway between 2 and 3, of course. Here we have a negative value in front of the x. And again, we're going to use the same method. Substitution. 2 take away 2 multiplied by negative 3. So be careful here. Negative 2 multiplied by 3. So it's 2 take away, the answer of this is a negative 6. 2 take away negative 6 is the same as 2 plus 6. So the answer is 8. Let's do another one. 2 take away 2 multiplied by negative 2. So we're using this x value. This is 2 take away 2 multiplied by negative 2. So that's negative 4, which equals 2 plus 4, which is 6. And look at the pattern here. We're taking away 2. And again, that makes sense because what value do we have in front of the x? Well, yes, we have a 2, but it's a negative 2. And because it's a negative 2, we need to take away 2 each time. So here we have a 4, here we have a 2, 0, negative 2, negative 4. And again, if you were to substitute these values one by one into this equation, you will see that all of these y values are correct. Now we need to plot the values as coordinates, and one difference I think we can see on this line is that instead of it going like that, in that direction, it's going in the opposite direction, and that's because the value in front of the x is negative.